All right, 10 o'clock. Everybody ready to get going? Everybody good? All right. Good morning, Victoria. As always, feel free to chime in on Slack if you have any questions or comments. Good morning, Vancouver. How was week 2? I realize that we are only 2 minutes in at this point. So far, so good. It's all uphill or downhill from here? It's got its ups and downs. Perfect. Okay. We are continuing on with some of the basics that we all need to know as web developers. And today we're going to talk about TDD, or test-driven development. You may have some inkling into this because you have written some assertions already last week. And we are going to use a professional library to do this. So we're going to utilize Mocha and Chai today. So as always, we start with our to-dos. We're going to practice writing unit tests, which is one particular type of test. It's the simplest test, luckily for us, using TDD. And we're going to get introduced to Mocha and Chai. And then we are going to create and consume modules using Node's default syntax, half of which you've already seen. You've seen the require statement, right? Const whatever equals require, right? So that's 50%. So we just need to do the other 50%, which is exporting those modules. Okay? Cool. So there we go. Good morning, Victoria. Okay. So right off the top, what is TDD? And I don't expect you to know this already. So we'll just, and TDD is test-driven development. In a nutshell, what it means is that tests are written before the code is written. So previously, you've been writing code and then submitting it into Compass, and tests are run against that. Whether you're conscious of it or not, you saw the test output. Instead, we are going to write the tests first, and then we are going to write the code that conforms to those tests. And this falls into the category of what you could call end-driven development. By the way, how is the font size in the back? Is it good? Awesome. Okay. Wow, that went off the rails. Development. There we go. Where end could be anything. You'll hear all these different things. We have test-driven development. We have behavior-driven development. We have component-driven development. They are essentially just, KV will talk to you about error-driven development if he hasn't already. So these are just various different ways that we can approach code, and all of them take the mindset of, let's put some thought into what we're going to do before we put our hands on the keyboard and actually start coding. That's essentially what it boils down to. So are we going to create all of our components first, which you'll see later in React Week? You'll create all of your components before you start styling your UI. Are we going to write all of our tests first before we get started? And this helps us to kind of stay on track, much like our to-dos keep me on track during lecture. Our tests will keep us on track. They'll keep us from writing too much code. They'll keep us from writing the wrong code. They'll keep us from writing code that we think works, but then someone else tries to use it and it completely breaks. Okay? So this gives professional developers, TDD gives professional developers confidence in the code that we write. And I want to differentiate between something else you'll hear. So test-driven development is more for us. We want to ensure the quality of our code. We want it to be robust. We don't want it to break, things like that. When you hear about behavior-driven development, or BDD, that's more from a user's perspective. So how would the external user utilize our code, either utilizing our API or using our front end, things like that. Like from a user's perspective, because that's where our money comes from, right? That's how we get paid, end users. Whether it's an ad-driven website or a revenue-driven website, that's how we get paid. So BDD is from the user's perspective, and it usually involves the entire team, like marketing will get involved, graphic design will get involved, things like that. TDD, test-driven development, is just for us. It's for us and other devs to be confident in the code that we are writing. Because when we have a robust set of tests, we can confidently add new features to our code base and make sure that we haven't broken something somewhere else. Because if tests fail, then your code doesn't get merged into master. At my job, we run a full test suite every single time we push code, whether it's on our own branch or whether it's on the master branch. Every single time, and if it fails, then there's a huge red flag. We get messages in Slack, your code failed, and here's why. And it's a little embarrassing. So make sure you run your tests locally before you push code. Any questions about TDD before we dive into Mocha and Chai and then get some examples going? Is it kind of making sense? Cool. Okay. So we're going to use two technologies. We are going to use, I'll scroll up a little bit, Mocha, which is a testing framework. So previously, when you want to run code, you'll type something like node myfile.js, right? So instead, we are actually going to write Mocha and then mytestfile.js. So it's literally its own application that runs outside of Node, okay? So keep that in mind. This is why we won't be requiring Mocha into our projects, even though we install it as a dependency, okay? So Mocha allows us just to run these tests in a particular way and reliably. And one of the things about Mocha is that by default, it looks, let's scroll up a little bit, it looks in the test directory for tests. We can change that. We can pass it different things. We can tell it explicitly, run this particular test file. But by default, it will look in the test directory for all of our tests. Now, on to any questions about Mocha? Everybody cool? Cool. Awesome. Chai. Chai is an assertion library. And an assertion is, I mean, you've already written them last week, but let's see what Google has to say about assertions. Let's make that a little bigger. A confident and forceful statement of fact or belief. So this is how we are going to write our tests. We're going to say, we have a function, and given these parameters, it is going to return this result. And we're going to be able to test, just like you did previously. You had assert equal arrays, and then you were testing a particular, are these two arrays equal, and does that output true or false, right? And we'll go through a bunch of different ways that we can test to make sure that our code is working as expected. And it's through all of these assertions that we can say, yes, we are confident our code is doing what we want it to do. So that's all Chai is an assertion library. And we actually have an assertion library built into Node called assert. There we go. So assert is actually built right into Node. You can require it into any project. Just you haven't had the TCP lecture yet. There's various different modules. When they took V8, does anybody know what Node is? Have you talked about that yet? About what Node actually is? Okay, so Chrome was written by Google, right? Chrome was created by Google. And the JavaScript engine, the JavaScript interpreter that it uses is called V8. And there's various different, so JavaScript is actually ECMAScript. Have you talked about that? The European Computer Manufacturers Association script? No? Was that the first time? Cool. All right, I get to talk about ECMAScript. Did you ever wonder why we call it ES6 syntax? Yes, exactly. It is particularly, it is the ECMAScript 2016 and forwards syntax that we're dealing with here. So a lot of things have standards. And how else could you write a modern web browser if you didn't have a standard? If it wasn't said, when someone types this in JavaScript, this is the expected result. How else could you do that if you didn't have a standard in place? So when they came up with JavaScript in the mid-90s, they shopped around to find different standards outfits. You've probably heard of something like ISO, the International Standards Organization, right? ISO 9001, stuff like that, if you've ever come from a manufacturing background. as Nima shared with me, there's actually an ISO standard for boiling tea. There we go. ISO 3103:1980 is for the particular way to boil tea. So if you're geeky enough, someone has written a standard about almost anything you can do. I bet there's a standard out there for how to tie your shoes. There is a mathematical way to tie shoes. You can Google that later if you're interested. So the European Computer Manufacturers Association took them up on the challenge and said, we'll take over this language. We will call it ECMAScript because Java is actually owned by Oracle, the Java programming language. It was named JavaScript to try and get new programmers on board. Okay, so they just tacked script onto the end. It kind of looks like Java, kind of looks like C. So the success or failure of a language has nothing to do with how good that language is, how robust it is, how many tools it has or plugins. It's 100% how well it's marketed. So when they came up with JavaScript, they said, we don't have a name for this. Let's just ask Oracle if we can borrow Java, slap script on the end, and away we go. History was made. So it is officially titled ECMAScript for the European Computer Manufacturers Association. There we go. And every year, they release a new standard that web browsers try to stay compliant with. Like we talk about ES6 destructuring or fat arrow functions, things like that. Those were all introduced from 2016 or newer. Okay? So these standards come out all the time, once a year. And where was I going with this? Oh, yes. OK, so Node. So Chrome had this V8 engine running in the browser. That was their particular JavaScript interpreter. Netscape Navigator has their own. Internet Explorer has their own. V8 is just the one that Google came up with. So they were like, what if we could write JavaScript on the server? Rather than having to write PHP or C or Python or something like that, why can't we just use JavaScript? What if we pulled the V8 engine out of Chrome and put it on the server side? And we'll call it Node. So that's exactly what they did. Somewhere around, how old is Node? It's somewhere around 2011. There we go. Just 9 years old whenever this was written, so 2009. But they had to do other things because the way that we consume files, the way that we work with files in the browser, and what we expect JavaScript to do for us is a little different when we jump to the server side. So there's various different libraries that we have accessible to us, built right into Node, but not brought in every single time because we don't want to pollute our global namespace, right? We talked about that, or you may have read about that as one of the things of functions, that you try to wrap variables inside functions so they don't pollute that global namespace. Because we have one global namespace, and you can fill it up with all these variables and everything. So there's various different libraries that we can pull in, like HTTP, for making HTTP requests, which we'll see later. They've got console, they've got domain. The one that we are looking at right now is assert for assertion testing. Now, you can see, if I zoom out just a little bit, this is the full extent of all of our asserts. So this is why we won't be using the built-in Node assert library. Because for comparison, when I said that chai was an assertion library, let's take a look at chai. Super tiny. OK, so these are all the things that are available to us with chai. And if you can see, I don't know if you can see how small my scroll bar is there. That's how many different, you see it there just underneath plugins? That's how many different assertions we have available to us. So that's why we are going to bring in another package rather than using the built-in Node assert library. Okay? It's much the same reason why we bring in any package. A, so we don't have to reinvent the wheel, and B, so it gives us a whole bunch of extra functionality right out of the box that we didn't have to write as developers. But bear in mind that under the hood, it's not adding anything new to our JavaScript. Like, we could have written these libraries if we were so inclined and had the time to write 100,000 lines of code. But why do that when someone else has done it and we can consume it for free? And it makes our code better, and we can just hit the ground running with what we want to do. That we stand on the shoulders of giants so we can see further is very, very apt in programming. Because we just, essentially, our programs will be cobbled together, modules from other developers. And we're just cobbling them together in some unique way. And that's what we get paid to do. Okay? So when you're out in the wild and you're working as a professional dev, if someone asks you to do something, first thing, Google to see if someone has already done it. And just bring that package in instead of writing your own from scratch. Okay? There is some merit to writing your own stuff. Like, we wrote our own for each, right, to understand what was going on. But this stuff will be far, far better than we can write. Okay? Far more robust, because it's been used by hundreds of thousands of devs. Let's go to npm chai. If I'm going to research a package, I will do the Google search prepending npm. Does everybody know what npm is? Cool. Oh, this is awesome. I got to give more week 2 lectures. Okay, let's search for npm. Build amazing things. Well, it certainly doesn't stand for that. Then it would be bat. Okay, let's zoom in here. So believe it or not, most people think npm stands for Node Package Manager. It actually means nothing. Okay, so here we have no purchase made, and we'll refresh. Oh, come on, give me a new one. Was my internet dead? Come on. I'm trying to give a lecture. What do you mean no purchase made? Oh, you're terrible. Okay, normally, I don't know why it's not happening right now, but this will refresh into various different humorous acronyms. Oh, I gotta click it. Thanks, Steve. Okay, numerous problems multiplied. Neoteric plumbing mishap. Node's power meal. There we go. Nostalgic piano music. Noble programming mantra. Non-polynomial mantissa. There we go. So you can think about it as the Node Package Manager. It is not the only Node Package Manager. There's another big one called Yarn. And if I just do a search for Yarn, that's not going to work very well. Package Manager, there we go. So you can also use Yarn. And it does essentially the same thing, just with slightly different syntax. And this is all, whether to use npm or whether to use Yarn, is a matter of choice. Throughout this course, we are going to use npm. Every lecturer you see will be using npm. That's a choice that we have made. But when you're out there, like at work, I use Yarn. Why? Because the senior decided we're using Yarn. And that's it. He said, I don't like npm, we're using Yarn. Fair enough. I'll do whatever you pay me to do. I'll type Yarn instead of npm. They have little subtle differences, but for the most part, they just search through all of the Node packages and install them on your machine so you can add them to your project. That's it. So your Vagrant machine has npm already installed. It came with Node. So if you have Node installed, you have npm installed. Okay? And you can actually use npm to install Yarn and vice versa. You can also use Homebrew and apt-get and stuff like that as well. Oh, National Park of Minnesota. There we go. Never push mistakes. That's a big one. OK. So if I am going to look for a new package, if I want to see, because you want to see, just like when you're buying something on Amazon, are you going to buy something with 0 product reviews? Maybe if it's something cheap, but you like seeing 255 reviews, 4.5-star average, right? You feel confident that you can buy that, right? You feel confident when someone says, oh, my husband is this size, and the shirt fit him perfectly, and it was a medium. You're like, cool, medium for me, right? Or is that just, maybe that's just me? Do you all go to stores? OK, never mind then. OK, so if I'm looking at a new library, I'm going to type in npm, and then whatever the name of the library is. So in this case, chai. And this will actually take us, instead of taking us where we searched before for chai, and it took us to chai's page, this will actually take us to npm's page for this particular library. And on the left-hand side, you'll see what is essentially their README file. from their GitHub repo. So they'll have various different things here. They'll have some advertising. They'll usually have some kind of installation instructions for you, some getting started. They might have links to documentation, things like that. But on the right-hand side, this is principally what we're concerned with. How many times per week is this package downloaded? And 2.7 million times is a lot of times, okay? We can feel confident that this code, and this goes to why reinvent. If this code is being downloaded 2.7 million times a week, someone else has already found the bugs in it. Someone else has already reported them to the dev team, and they've been squashed. If we open this up and it said 27 times a week, we might be like, let's look for another package. You know, that might be fun for a side project, but that's not what we're going to use for right now. You can also link through to their GitHub repo, and you can see things here like how many stars does a framework have? And you can actually star it yourself if you really like using this, to show other devs, you know, I like using this. It's been working for me. You can go to their issues page to explore around and see what kind of issues are happening. You can see closed issues. You can see various different pull requests. You can contribute to this code. Anyone can. You can look at their pull requests. You can look at any of the open issues. You can say, hey, incorrect use of @namespace JS doc tag should be @member of. Sure, that's probably a thing that needs to be dealt with. And you can click into them. And you can see, so this came from some member of the community, more than likely, who found a bug in the code. And they'll write up, here's an issue that I found with your repo. But oftentimes, since these are all available for free, there's not a lot of, unless there's somebody getting money from Patreon or something, these people have full-time jobs. Like the people who wrote Chai work somewhere else, and they're doing this in their spare time. So they don't have the time necessarily to squash all of these bugs. So they're more than happy if some zealous web developer somewhere wants to take it on. And it looks great on your resume. So there is actually, I believe, in Compass, there is a stretch thing throughout the course to contribute to open source software. And you can do various different searches. There's different libraries online for new developers, you know, people with not much experience, stuff like that. This is a great first issue for you to tackle and deal with. This is also the way that my workplace and a lot of workplaces deal with issues with your own code. We write up, here's an issue. And an issue doesn't necessarily have to be a bug. It could be a feature improvement. Issue, we need to have users be able to log into our app. Issue, we need to have users be able to friend each other. Issue, we need to be able to handle JPEG, PNG, SVG uploads. And you'll just tackle these issues. This is actually the workflow that my team uses. We're all assigned issues. We work on them till we're done. We submit the code, and we grab a new issue off the stack. So, Chai looks pretty reasonable, right? 2.7 million downloads. That seems pretty good. So, there we go. So that was a bit of a tangent. This is why I need to stick to these to-dos. So, that's Node. It's the Chrome V8 engine slammed down to the server with a bunch of extra bells and whistles put in that are fully optional, as well as Node, the open source software that surrounds Node, is the largest open source project that humanity has ever created. So all of the packages for Node. And it keeps growing every single day. In fact, I'll show you how to increase it today with your own code. So, alternative to Node's built-in assertion library. I keep forgetting the R in assertion. There we go. Okay, so that's why we use Chai. And now, before I bore you to tears, why don't we actually start writing our own tests? We're going to practice test-driven development today. So, I happen to have Mocha installed globally. Let's jump over to Mocha so that we can see that. So the very first thing you want to do if you want to install something is we go to Mocha npm here, and we can see that there's This is all of their backers. Like I said, without sponsors or without Patreon or something, this is just done out of the kindness of their hearts. So let's jump into the documentation. Make that a little bigger. And we'll go down to table of contents, installation. So we have a couple different options here for installing Mocha. We can use npm install -- global, which would install Mocha on our operating system. Essentially, it'll be available in any product, any project, any folder, anywhere. I have it installed globally, so I can type Mocha anywhere I want, and it will look for test files in that directory. Okay? The other option is we can use this flag. Have you ever seen this flag before? -- save dev? Okay, what does -- save dev do? Oh, but you've seen it before. Perfect, awesome. Okay, so there's two different types of dependencies that you can have in a project. You can have project dependencies, but they also added an extra one for dev dependencies, as in during development. Like when we deploy code to a server, to a production server, and it's actually running, we don't need to run Mocha against that because we did that when it was in development mode. So we don't need to add that package to that server. So what npm will do, or yarn, is they'll look through your dependencies, and they'll always install everything you have under dependencies, but they'll also look at your environment. And if you're running in production, then they will not install your dev dependencies, just to keep your loading size down, and to keep files that you don't need from your system. But if you're in dev mode, they will install all of your dev dependencies. Okay, so you have access to Mocha and anything else you're using. If you're using something like TypeScript or another compiled language, then your compiler would go in there, things like that. Okay? So we have a couple different options today for installing this. Why don't we go through this option here, save dev, so I can show you what it does. Okay, but I am in a, yes, absolutely. Any better or bigger? Sure. There we go. Okay, so I'm in a brand new directory. If I run git status on it, I have no repo running right now. So I'm going to git init to get my repo going. And then if I run git status, I see that I'm on branch master. No commits yet. And all I have is my README file is untracked. Okay, so I'm actually going to clear this again. I'm going to add everything. Run git status again. Remember, that's a good workflow. Git status, git add, git status, to make sure that you haven't inadvertently added something. Okay. Okay, so now I have a new file that's staged for commit, README. So I'm going to say git commit -m initial commit. Perfect. Run git status again, and on branch master, nothing to commit, working tree clean. Perfect. Okay. So if I want to start a new project, I can't just type in npm install -- save dev Mocha. I need to create actually a node module myself. And we do this with npm init. So just like we git initted to start git in this directory, we need to npm init to start npm in this directory. And that will let npm know that this is a module itself, and we're going to consume other modules in our code. So npm init, enter. And it's going to walk us through, as it says here, it's going to walk us through some various steps to create a package.json file for us. Okay? So package name, September 16th, week 2, day 1. Sounds good. You could just hit enter to accept the default. It'll show you the default in parens here. Version 1.0.0. Sounds good. Description. Lecture notes on TDD with Mocha and Chai. Entry point. So I don't know if you've come across it yet. Have you done npm start? Something like that? OK. This entry point tells npm or yarn what is the initiating file for you? Normally, if you're running a server or something like that, you have one file that you're going to start up. You'll node server, and it will include other files or not, whatever it's doing, and it will start running. So we can tell it, this is the entry point for our application. If you're looking in this directory, this is the entry point. By default, I don't know if you know this, on the browser side and on the server side, the default name for a file that any runner will look for is index. Index.html on the browser side. You've probably heard of index.html. And index.js on the server side. So we're not actually going to use something like npm start. So we can actually just leave that at the default. But if you had something, you could type in server.js, something like that. So we're just going to leave this. And I'll show you afterwards. This is just a little helping tool to help you quickly scaffold out a package.json. This is not an all and done. You can change every single one of these answers after the fact. Okay? Test command. Well, we'll get back to this in a second when we start running Mocha. But if you already knew your test command, you could type it in here, and we'll run Mocha. Git repository. That sounds like a plan. We'll go to GitHub. We will create a new repository. Usually I do this after a lecture, but September 16th, week 2, day 1. There we go. Lecture notes and examples for week 2, day 1, TDD with Mocha and Chai. And when I create this, create my repository, it is going to give me a way to connect. You can either use HTTPS or SSH. You will all be using SSH because you had to set up your SSH keys as part of the prep program, right? This is a lot better, I find, because you don't have to enter your username and password every single time. But other than that, there's no real difference between HTTPS and SSH. They're both encrypted. So I'm going to copy that. I'm going to head over here, and I'm going to say that that is my repository. Keywords. Well, if we had keywords, we could put in Mocha, Chai, TDD, fun, that kind of thing. Author. There we go. You can include your email address. You can include anything that you want in here. And license. By default, it goes ISC. Why don't we say MIT? If you're curious, you can look up what all the different open source licenses do and what people can use your code for and what they can't use it for. And it's all defined by this license here. Okay? And then it shows you on the screen, this is what your package.json file is going to look like. It is obviously JSON. Are you familiar with JSON? Have you seen JSON? Yes, no? It kind of looks like a JavaScript object, except for the fact that by default, well, actually, it has to, the keys have to be strings, and they have to be definitively strings. Okay? So other than that, it looks essentially exactly like a JavaScript object. Okay? So we see that the name is what we told it was the name, the version, the description is exactly what I typed. Like I said, you could do this longhand if you wanted. You could type out your own package.json. But most devs find it helpful to just do npm init, and they get these questions that they can answer. And you'll see that it actually created an array of keywords, including the most important one, TDD. Right, okay. So is this okay? Absolutely, there we go. So if I clear this and I check my directory now, I now have a package.json file there. And if we go into VS Code, there it is. That's the exact same thing. And I can get in here and I could change anything. You'll see that since I didn't say anything for my testing script, it's going to just write something into our console. Let me try that out. So I'm going to try and run npm test. Error, test failed. See above for more details. Great. No test specified and exit with a 1. So this is probably a little bit too much information for right now, but if a running program exits with any other code than 0, there's an error. So they're just saying exit with a 1, there was an error, no test was specified. Okay? So that's all these scripts do. You can name them yourself. You can go in here and say this is going to be something like testing, and then you can go in here and you npm testing, and oh, it didn't like that. npm run testing. There we go. Error, no test specified. Okay, so you can customize these however you like. It's a lot of fun once you get into it. Once you get used to the fact that you can extend this however you want. You can do whatever you like. This is just an object. You can add more stuff here and have it run some code. Maybe we want to do rm-rf node modules, something like that. Maybe we just have a thing that we run to remove node modules. So now all I'd have to do is type in npm run remove node modules, and it will run this command for me. Okay? Cool. Oh, too far. There we go. So back in again. Okay, so now that we have npm set up in our directory, we can now install npm install save dev Mocha. So I'm going to run this. Npm obviously is the command that we're going to use. Install, we want to add a new package. Save dev, we want to save it to our dev dependencies, and then the name of the package. And so now it's actually going to fetch it from the package repository and pull it down to my computer. Cool. So it did a couple of things for us. It said that it created a lock file called package-lock.json. It recommends that you commit this file into your Git repo. So if we ls-l, we see that we now have a node modules folder and a package-lock.json that were created for us. Package lock, if we take a look at that, package-lock.json, simply, it looks very similar to package.json, but all it does is it records a specific version of a file. So if you were saying, because these things come out all the time. Remember we had to type in 1.0.0 when we started ours? Let's say we had made changes to the code. Well, we come out with 1.0.1. And so this records what is actually installed in your project. Like this particular version has been installed with this project. And you can use this package lock to make sure that every member of your team is using the exact same version. That you're not getting some kind of weird thing where they added some new functionality and other members of the team don't have it. Okay? So you never, this is a completely generated file, never manually edit package-lock.json. Okay? So let's look at our package.json. Remember what we had before? We had our repository and our scripts that we were playing around with and our keywords. If we scroll down a bit, we see that we now have a dev dependency. This is what --save dev did for us. And we see that it's Mocha. And here, to illustrate a little further, so this caret here, there's various different options that you can do. This caret says 6.2.0 or greater, whatever it happens to be. Let's say 6.3 comes out tomorrow, and you clone my repo and run npm install, you'll get 6.3 tomorrow, as an example, or 6.2.1 or something. We're saying definitively this or greater. That's what the caret means. There's various different options here. You can also say, I just want this version. Okay? But by default, if you just run npm install, this is what we'll get. We'll get npm install with the caret. And this, hopefully that makes a little more sense with the package lock file about the versioning. Does that make a little more sense about why we have the package lock file? Because in our package.json, we didn't explicitly say this particular version, we said this one or greater. So the package lock file says we installed this particular version of this particular dependency. Okay? There is. In the weekend work, we're using the command npm install mocha chai --save dev. Is there a difference between that and what you did to install? Does it matter where the save dev flag? For the most part, no. It doesn't really matter. Quite a few of the flags, you can just mix them around. So the question was, is there a difference between that and and what I ran. And for a lot of programs, they'll be able to handle these arguments in any order that you pass them in. Okay? So I literally just copied what the developers had said. That's how to install the package. You can do -- save dev after the fact. Yes?
Do you recommend installing Mocha and try globally so that you never have to worry about continually installing it in a specific project?
Well, as you can see, that's what I did. And it's entirely up to you. It's a preference thing. Do you want to have that available? Because sometimes you can run into, you installed Mocha, but you installed it a year and a half ago, and now it's out of date. Whereas if you have it with this particular project, you know you're always running the latest version of it. So does that kind of answer your question? Yes.
Like if it was globally, there would be no way to update it?
You can update it. You can just install it again, and you'll pull it down again. So if I ran npm install -- global, or -g is the shorthand for that, and then Mocha, it would just reinstall it and overwrite what I've got.
And if you already had save dev, if you've already done that a couple times, and then you wanted to do it globally, would it get rid of those?
No, the ones that are save dev are particular to that project, and it won't overwrite that. Were you saying if I ran npm and -- save dev again, would I get the latest version? In our dev dependencies? Is that what you're asking?
I guess I was just wondering, like if you do it globally after you've already done it within projects, like if it doesn't really matter from that point on.
Right, you can think about it as two completely separate environments. Either you do it globally, or you do it in your project, or you do both. The difference is how you invoke it. So obviously we have node installed globally, so we can run node and then whatever file, right? If we have Mocha installed globally, we can just type Mocha. If we just have it as a dependency in a project, we have to actually get into the directory to find it. So we go, if we take a look at our node modules, oh, that didn't do what I wanted. We can actually see, I'll just make this slightly smaller for a second. There are an absolute ton of modules that Mocha itself needed, that it depended on. And those have dependencies that they depend on. And that's why we have all of these files now, or directories, in our node modules folder. So if we go and look for Mocha, and then we get into the binary, we have to run this Mocha file. So if it's part of our dev dependencies, then we have to dig into node modules, /node modules, /mocha, /binary, /mocha. And we'll see that that does exactly the same thing as that. This was installed as a dev dependency, and this was installed globally.
So if you have it in a dev dependency, if you've installed it in a dev dependency and globally, and you're within that project, and you call Mocha, does it go to the global one, or does it go to the...
If you call Mocha like this, it will look for it globally. You have to, if it's installed as a dev dependency, you have to dig into the node modules folder. So this is one of the reasons why. So if we jump back to here, like we want to run our tests. Let me make that a little bigger. Let's say we've done this as a dev dependency. I don't have it installed globally. We want to run our tests. Let's just dig into node modules, /mocha, /binary, /mocha. And now, when I do npm run test, I get no test files found. Okay? So instead of having to dig into it every single time, you can just set it up as a script. That way you can just do npm run and then the name of the script that you set up. Okay? So this is how you do it if it was a dev dependency. Okay? The other advantage to dev dependencies is if you share it with someone who doesn't have it installed globally. Then when they do npm install, they'll get that package, and then they can run npm test, or npm run test, and then everybody's on the same page. And you haven't forced some member of your team to install something globally that maybe they don't want to. Okay? Fabio, you had a question? Did you? Okay, awesome. Any other questions about that? I know this is kind of a lot to dump on you right now, but you'll get very used to package.json. You'll see it in every single node project that you create. Because every single node project that you create is going to be itself a package that you could deploy to NPM if you wanted. If you wrote some new library that you're very proud of, you can deploy it. And maybe you'll get to 2.7 million downloads one day. Okay? So that's actually what we're creating right now. That's absolutely what we did when we ran npm init. We created our own module that someone else could consume. Okay, so now we've got our Mocha installed. We've got our test script set up. The guiding principle behind test-driven development is something called the red-green refactor. Has nothing to do with duct tape. Ah, a laugh. Perfect. One in every cohort, that's great. If everybody's old enough to remember red-green. Okay, awesome. Not my joke. Awesome. So the red-green refactor, we've already seen the red. The red is a failing test. Okay? So this is kind of what we want. We want to write all of our tests up front with no actual code. So by default, all of our tests are going to fail. Right? If you ran the testing suite, if you can, if they don't have any error prevention in Compass, if you just tried to run it without pasting your code in, all the tests would fail, right? Unless they were expecting absolutely nothing to come back. Then they might pass, kind of by accident. But we want to, red, tests are failing. That's pretty easy to get at. Green, tests are passing. And here is the most powerful part of the whole test-driven development mindset, is the fearless refactoring. So have you ever tried to play with your code and you say, I used a C-style for loop, but what if I switched it to a for of? And then you run your code and it's broken, right? Or it didn't quite work. This is what's so great about test-driven development and this testing suite, is if you have the tests and the tests are working, you're testing every aspect of your code, and everything is passing, you can start fearlessly playing with different parts of your code, because if you screw up, the tests will stop passing, right? So you can tell if you've broken something. Rather than someone asks you to refactor some code, you're like, I think it's done. I think it's going to work in every case. But you don't actually know until somebody tries to break it, right? But if you have a testing suite in place, then you can just go ahead and start pulling things out and refactoring all over the place, safe in the knowledge that you're not done until all the tests pass. Yes? I only commit, personally, I only commit working code, functioning code. Well, it depends on, I might do a git commit and say 2 out of 5 tests passing, something like that. I like to think of my commits as checkpoints in a video game. So you have been coding for long enough that you've probably coded to the point where your code works, and then you continued coding without committing, and then your code doesn't work anymore, and you don't know where to go back to fix the mistakes. Does that resonate with everybody? If it doesn't, you will, and then you'll be like, I should commit my code more often. So I think of my git commits as just checkpoints in a video game. If I know that it's working right now, so if I move forward and I die to the boss, well, I'm just going to come back to here. If I start playing around and I bring in some packages and they don't really do what I want, well, fine, I'll just go back to my previous commit and I'll just continue on again. That's my basis of working code. I know that I always have working code, okay? You can commit as often as you like. And GitHub is actually set up for this, and they kind of reward devs for committing as frequently as possible. You get these green squares. Look at these green squares. Aren't they great? And the darker the green, the more contributions you've done, okay? And this could be anything. It could be creating issues. It could be doing code reviews, whatever. But GitHub actually counts your contributions. So the more frequently you commit, the more it looks like you're actually working. Cool? Okay. But when to commit, that's a matter of preference for the dev. Okay? So you can do more or less of this refactoring afterwards, but our purpose is to write the minimum amount of code to make the tests pass. And that's it. The very minimum. Like I said with our to-dos, which are failing me today to keep me on task, our tests keep us on task as devs. It keeps us from writing extra code that doesn't really do anything, and it also shows us where our code is falling down. Okay? Cool. So I think we are ready to bring in, how are we doing for time? 10:52. Let's bring in Chai. So if you're not sure how to bring something into your code, how to get started with it, yes?
Do you know a way to create an alias for, like, instead of typing git commit, like, have it short?
Yes, absolutely. I can show you. Oh, for Victoria, the question was, is there a way to alias your git commands? There absolutely is. There's something called the git rc file. And I have aliased all of my git commands because it's too long to type out, and I'm lazy. So instead of git push origin master, I type in git pom. And it'll do the exact same thing. I can show you over break or later on if you're interested. And anyone else who might be interested, just let me know if that's something we should cover as a whole or just an individual thing. Cool. Any other questions before we install Chai? Awesome. So, and remember what I said about adoption? I wonder if Chai would be as popular if it wasn't named after some kind of coffee drink. Because devs love coffee, right? So if they had named it anything else, would it be as popular? Who knows? Who can say? So we want to figure out how to install Chai. Hey, look at that. You can just jump down to the code examples. npm install Chai. Great. Remember, you always have Google available to you. This isn't like university. You're not going to sit down with a test and they say, put all your books away. You always have your Google available to you. Okay? So npm install Chai, that looks great. But I don't necessarily want to use npm install. Like I said, I'm lazy. So I could do npm I Chai, and it will do the exact same thing. Except we want to make sure that we pass save dev. Right? We want to save it as a dependency, as a dev dependency. If you don't pass this, in the old days, and you might see some documentation, you used to have to do this, -- save, to save it as a dependency, as a project dependency. Otherwise, it would just save it globally by default. You don't have to do that anymore. By default, it saves it as a dependency if you don't pass anything. So we can save dev. But this I is not our only option here. We have install, we have I, and we have my personal favorite, isn't all. Any guesses as to whether this is going to work or not? I kind of spoiled it. Oh, perfect. Terrence, interested in the git pom. Awesome. So that totally worked. Can you guess why? Let's look at the man pages for npm. Are you familiar with man pages? They are. It has nothing to do with gender. It's short for manual. It's digital manual that's built into Node. You can just type in man and then whatever the name of the command is, and you can look up documentation. So let's jump down to developer usage, configuration, contributions, bugs, see also, npm install. Am I not going to get it here? Nope, apparently not. Okay, Q out of there, npm man, npm install. That just gave me npm again, didn't it? Okay, at any rate, I'll dig into this over the break. But the thing is devs were spelling install wrong. So instead of that failing every time, they just aliased isn't all to do the same thing as install. And that's one of my favorite things. It's just, so that absolutely works. If you feel like typing that in, that's great. Most of the time I just do npm I. Okay? So if we check out our package.json, we can see that we now have another dev dependency in there, Chai at greater than or equal to 4.2.0. Okay, so why don't we take a 10-minute break, and then we'll come back and we'll start writing some tests around some functions that we'll write. Okay. Why don't we jump back in? It's 7 after. We have 53 minutes to write some tests. Okay, awesome. So if everybody's all set. Okay, so when we do npm run test, remember that was the script that I created in my package.json so that it uses the Mocha that's in my node modules folder. We get our very first red. Remember I said that we're going to use red-green refactor? Okay, awesome. So this is our very first red. No test files found in test. Remember that I said by default, Mocha looks inside of the test folder for tests to be written. So, and if we clear this and we ls-l, obviously we have no test folder. So if I make a test folder, let's find out what happens. ls-l, perfect, npm run test. No test files found. But you'll see that's a different error than no test files found test. So it's saying that there was no testing directory. Now it's saying that there are no test files in that directory. So we're slightly closer. Okay. So we need to create some kind of function. I don't want to do like a simple math library thing or something like that because I think that math is kind of scary. So why don't we do string manipulation instead? Okay? Because then we're not getting into what is 2 times 3. It's more like hello Andy and stuff like that. Nice simple things, okay, that we can test against. So let's touch a new file. And usually what you do is you name it after. So if we had, kill this. So if you start typing, I think I showed you this, but you can just hit Control-C and you'll just kill whatever you've typed. So if we had something called like string manipulation.js, then the test file for that would be string manipulation.test.js. Okay? So first off, since we were doing TDD, we're not going to create our function first. We're going to write all of our test files first. Just like months before you started, all of those tests were written for you to submit your code in Compass. We're going to write all of our tests first to define the functionality that we expect, and then we're going to write a function that satisfies that functionality. Okay? So let's touch, and let's just call it strmanip, just so I don't have to type out string manipulation every time. Oh, and we want to make sure that we put it inside the test directory. Okay? So now if we ls-l test, we see that we have one file in there. Now let's see if Mocha complains. Oh, hey, we're making progress. Yes. Oh, you can actually put anywhere in there. This is, you can do this in your files. You can put a dot whatever. So this is just my way of saying that this is a test file. You could have done dash test. You could write test. You could prepend it with test. But periods are valid in file names. You're not just limited to one. It's not like an @ symbol in an email address or something. So you can name your files this dot this dot this as long as you end it with a valid extension like .html or .js or .ts or .css, something like that. Feel free to drop in a period wherever you like. Yes. Yes. So for Victoria, the question is, if you put .html.js, what would it interpret that as? It will interpret it as whatever is on the end of the file. So if it's .js.html, it'll think it's an HTML file. This is the file extension, this last dot, whatever it is. Everything else is the file name. Okay? Cool. So hey, look at that. We went from red to green. This is fantastic. So now it's telling us, I found the test directory. I found a file in there to run, but there were 0 tests, so we have 0 passing. And thankfully, for us, Mocha considers 0 to be a positive thing. So if we need to get to at least 1 failing to get some more red. So why don't we write some tests? So if we go back to, let's get rid of this. Oh, there we have Mocha open. OK, npm install Mocha, make a directory called test. This is just saying whatever your editor is, open that editor. This could be vim/test. It could be VS Code, whatever. See, open with your favorite editor. OK, so they use assert to bring in the node assert library that we talked about. We're going to use chai instead. But we see this is what we need to focus on. This is what Mocha gives us. This is what it expects. It expects a describe, which takes a name. So this is where you would describe the function or file that's under test. So if you were testing your server file, you'd be like describe serverfile.js. And then what is this? We talked about it on Thursday. Right? Callback. Yay, thank you. Awesome. This is a callback function. So it takes a string, whatever the name of the test is, whatever you're going to do, and then a callback function. And you can nest these describes however deeply you want. Let's say you had a file that exported 10 functions. Well, you'd have a describe for the file itself, and then you'd have a describe for each one of the functions. And then inside of there, we get to move on to the actual test itself. And we're going to start writing these, but I just want you to take a look at this. It starts with it. This should be like human readable. You want to say like, it should do something. It should return -1 when the value is not present. It should return hello Andy when passed the name Andy. Stuff like that. This is where you're saying, this is what it should do. This is human readable. This is what will actually print out in the console when we run our testing suite. Okay? And then, I told you we'd run into these all over the place. Callback function. Okay? Then it takes a callback function that actually starts to use assertions to test. Because it's not enough for us just to say, well, it should return hello Andy. We need to definitively test that. We would have to call our function and then assert. Remember what assert means, to strongly say this is what's going to happen. We would have to test. So this side is running the function so that we have assert equal. So we're saying we're making an assertion that these two values are equal. So whatever's on the left of the comma, and then whatever's on the right of the comma. So see where it says should return -1 when the value is not present? Well, index of 4, there is no index of 4 in 1, 2, and 3. It's only got 0, 1, and 2, right? So return index of 4, -1 comes back. So this assertion would pass, just as you did with assert these two arrays are equal, right? Or assert lighthouse in the house that L or E or something came back with the array of character positions, right? You were writing assertions. So this shouldn't really be anything new. It's just a different way to do it, okay? Awesome. So let's start writing our own tests. So we'll jump into our test file and string manipulation test. Okay, so we are going to describe. And the reason why we have access, if it's not clear, to describe an it is because we're not running a node file. We're not going to run node strmanip.test.js. We're going to run Mocha. And Mocha gives us access to these describes and its. Okay? So tests for, I'll make that a little bigger. Tests for str-manip.js. And it takes a callback function. And devs are lazy, so we're just going to use a fat arrow function. Okay? We could write the whole word like they did, function, and spell it all out. But like I said, the most common use of anonymous functions is fat arrow functions. So we can just very quickly inline a function here. You could also, as we talked about last week, name this function and store it in a variable and then just pass the variable's name. Okay? There's nothing new that we're doing here. We're just learning about Mocha and Chai. You've seen all of this before. Okay? So inside of here, I like to, this is just a personal thing, I like to put white space to show in between each test this is what's going to happen. Okay, so our function, it, let's say we're going to pass in a name and it's going to say hello name. Okay, so it should return hello Andy when passed Andy. Okay, fair enough. And I'll just put this in quotes here. and then yet another fat arrow function. See how quick it is to type it all out? You just, OK. So here we are. Anyway, let's jump back over here. OCD, that's the word I was looking for. My OCD makes me put a carriage return at the end of every file. Yes?
Whenever I type it in that first parentheses, it press into instance of.
Oh, yeah. It's because VS Code is trying to be too helpful. So sometimes you really have to fight with it because it's going to try and give you various different things to help you out. If you want to avoid that, just hit escape. And that goes away. Yes?
How come the example had like a describe and then a describe?
Oh, like I said, you could nest these. Let's say we had a file that had 10 different functions inside of it, and each function is going to have 3 or 4 tests. Instead of putting all of those tests together in one giant describe, we can break it out into smaller describes.
And is that like when it says index of right before the function?
Yes.
Is that an identifier or is that?
Oh, in here? Oh, index of.
Second describe.
Oh, the second describe down. Oh, here?
Yeah.
This is just saying that's what we're testing.
Okay, so it's not like you were misspell that or whatever.
No. This is simply a string, and I'll show you that in a second. This is what's going to output to the console so that we as devs see what is in particular is being tested right now.
And the hashtag indicates function?
That's just their particular way of writing it, their naming convention. It depends on where you work and what you're doing. I've never seen this particular hashtag before. Yes?
Is there a reason or a way you would call only one of your outer or inner describe?
Essentially, normally you would break out, like I said, you've got a particular file, and that file under test has a .test.js. For Victoria, the question is could you run just a particular test inside of here? And to my knowledge, you can't. You can run a particular file, because what it will do is Mocha will look in your testing directory and run every single file that's in there. So you could pass it a particular file instead if you don't want to test your entire code base. But I don't know of a way to test a particular function other than commenting out all the other tests and just running that test in particular. OK. So yeah, when you saw instance of, it was just because VS Code was trying to be too helpful. It depends on, you can install plugins, and we can talk about this afterwards. You can install plugins for the various different languages that you use or the various different frameworks that you use. And it will make VS Code a little bit smarter and a little bit easier to work with. OK, so it should return hello Andy when passed Andy. So the first thing we're going to need is we are going to need our chai library. So chai actually gives us 3 different flavors. And this is entirely dependent on the developer, how you prefer to write. We have should, we have expect, and we have assert. So here's the flavor of should, foo, so the name of your variable. You'll see foo in bar a lot in documentation. Foo should be a string. You'll see that this is very readable. Or expect foo to be a string, or assert type of foo is a string. These all do exactly the same thing. They're just different flavors. They all test to see whether the variable foo is a string or not. Okay? So either you will decide whether you're going to use should, expect, or assert, or your senior is going to tell you, this is how we write tests. We always use assert, or we always use should. There's no real difference between these two, but you can see that foo, this should library actually adds on. It extends the functionality of our object, whatever it is. So whatever this variable is, well, if we didn't give it a should property, where did that come from? It actually changes the structure of the object. It wraps all of your variables in a bigger object so that we have access to should. So that's the main difference between should and expect and assert. And I have a link in the lecture notes I'll send you out of the actual differences between the 3 different ones. Okay? So we just need to pick one of these and settle on it. So do we like assert? We've already been using assert. Okay. So var assert equals chai dot assert. That's how we bring it in. So we're going to use const assert equals chai dot assert. Now, what does this tell us about chai? If we're able to access a property on it with the dot syntax. It is an object, absolutely. So what we're doing is we're pulling off a particular method. We can tell it it's a method because down here, actually it's an object because we're saying assert dot equal, assert dot length of, assert dot property, things like that. So we could do it like this, assert equals chai dot assert, or we could use ES6 destructuring and just pull the assert property off of the chai object. Okay? Which one are you more comfortable with at this point? Dot. Okay, let's jump back to dot. Okay, so const assert equals chai dot assert. So now we have access to, we could also just say const chai equals chai, and then every single place we just call chai dot assert, but it's extra we have to type. Yes?
On the weekend, it had us, like, when you go const assert, it would say equals and then require.
Oh, yes, sorry.
I thought you get rid of require.
Sorry?
I thought you could get rid of require someone. Say that?
You're right, we do need to require, yes, I don't think that the previous way that I had it written out would succeed. You have to require in order to bring in a package. Okay, so now we have assert, and this is telling us. So let's see what Mocha thinks of our code now. npm run test. Whoa, we actually have a test that's passing. So by default, if you just pass in an empty test, it will pass. Okay, so we're seeing that now, and you see that tests for str-manip.js, well, that's this string right here. It should return hello Andy when passed Andy. Well, that's this string right here. So you can see that these are just describing the particular function that we're testing and the particular thing about it that we're testing. Okay? So that's what's showing up right here. So let's actually put something in here. We are going to name our, let's put it right here. Actually, let's make it fail first. So our thing is going to be called str-manip, let's say. Or actually, we'll do str-manip. Say hello. I like it. So we're actually saying that this is what the name of our function is going to be. Before we've even created our file, our test is saying this is the name of the function under test. Is going to be say hello. So if we look at our assert, we can use assert.equal. I'll make that a little bigger and we'll move over here to test values against each other. Okay? So I'm going to split this into two different things. You can do it all in line over here, like they were doing with that index of, where they were in chai, they were doing everything all in one line. We can actually just do this. We'll say hello, and we'll pass in Andy. So now we've actually stored the return value as output. And now we're going to use assert.equal output and hello Andy. Okay? Now let's run our test file and see what happens. npm run test. Error. Reference error. Say hello is not defined. There's our red again. Okay? So how do we fix this issue here? Say hello is not defined. We need to define say hello. So const say hello equals function. There we go. There's the minimum I need for that. And let's run our test suite again. Ooh, there we go. If we scroll up. So red, this test has failed. We see that we have 0 passing, 1 failing, and the test suite took 10 milliseconds to execute. We see tests for str-manip.js inside of there should return hello. Expected undefined to equal hello Andy. Have you seen any outputs like this last week in Compass? Right, same thing. So it's saying your assertion failed. You asserted that output was going to equal hello Andy, But what do we get back from a function that we don't define the return value on? Undefined. So it's testing. This side says undefined, and this side says hello Andy, and those two are obviously not equal, right? Okay, so let's make this pass. Return. Everybody happy with that? Let's run our test suite. Hey, look at that. It actually worked. Does it seem like cheating? Because it absolutely is. This is where you can get stuck. This is called happy path testing. This is, we tested it, it's supposed to return true, or it's supposed to return this particular value. It does in this one particular instance. All my tests are passing. I can move on with my day. Well, let's write some more tests, because that doesn't seem right to me that we can just return something like that. So, should return, and I'll put this in quotes so it's a little easier. Should return, oh, quotes. Single quote. Hello, Kathy. When passed Kathy. Callback function. And like I said last week, this is great for code folding. You can fold up all your previous tests, so now all you see is the name of the test. And you can keep your code nice and tucked away. Okay? Const output equals, say, hello, Kathy. Did I actually include Andy in there? Yeah, I did. Perfect. Assert dot equal output and hello, Kathy. Okay, what's going to happen now when we run our tests? We have one passing, took 9 milliseconds, and one failing. And we see that it says expected hello Andy to equal hello Kathy. So our hard coding of the value kind of failed us here. Okay, so what do we need to do to our function to make sure that it passes both of these tests? We need to add a parameter. And then we need to interpolate that parameter into here, right? There we go. Hello, name. Now let's run our test. Hey, there we go. We have our tests here, and we have two that are passing. Took 7 milliseconds. Should return hello, Andy when passed Andy. Should return hello, Kathy when passed Kathy. So it seems like we were able to write a function that is testable. And now if we were to refactor this, it would be hard to refactor this because it's one line of code. We would be safe in the knowledge. Let's say I told you, hey, I don't like that form of string manipulation. Let's do this form of string manipulation. I just refactored the code. How do we test to see if it works? We just run our test suite again. npm run test. Oh, it didn't work. See? I refactored. I thought I was being smart, but now I have two failing tests. Because what did I forget? I forgot the space. You see how that if you were writing code on a server or something, you might be like, yeah, this is equivalent to what was there before. I can move on with my day. The tests are catching that. The tests are saying, no, hang on a second. You need a space in there. So this is where I was talking about the fearless refactoring. Okay? Is because we can be safe in the knowledge that we could play around with our code, and then we just run our tests afterwards to make sure that we didn't accidentally break something. And if we have our testing suite, meaning we're testing multiple different parts of our code, we didn't accidentally break something somewhere else. Okay? So, any questions about describe, it, and Mocha and Chai? Anything? Anything from Victoria? Yes? You cannot. This is as low as you can go. This is a particular test that's being run right here. For Victoria, the question was, can you nest it statements? And you cannot. This is as low as it goes. So we use our describes to dig deeper into the file system. And all that would do is, I can show you very quickly what another describe would do. Another level deeper, and it takes a callback function. and then I can cut these its and just put them right inside here. And now, so we have a describe inside of another describe, and when we run our tests, we'll see that we have the tests and then another level deeper. And you can nest these things infinitely inside of each other to get down to what particular line of code or what particular functionality you're testing to make it easier when these tests start failing to know where to go back to. If you just had 40 tests in one file and things start failing, you'll spend a while going, where is that line of code? I don't know. Okay, so before we move on to some of the katas from the prep course and writing tests for those, let's figure out how we can, because this is considered extremely bad form, to have your test file and your file under test in the same file, okay? And you can see how this would get very unwieldy if your functionality was 100 or 200 lines of code, and then you also have 100 or 200 lines of test, right? These don't work very well together. You want to be able to, maybe your senior gives you the test file, like we did with Compass. We had already given you the tests. When you do your mock tests, those tests are already written, right? They're not directly coupled to your code that you're going to write. So this is the other part of what we're working on, creating and consuming modules. Okay? So we already know that we can require. So if we cut this code out, save that, and we're going to touch str dash, what was it, str dash manip.js. So if I ls-l, we see that this is actually in the top level of our code, okay? Outside of our test file. So now let's go into there. Outside of the test package, there we go. And we paste it in. So now we have a file. This is what we had been doing before, right? Now you would, if you were going to test it, you'd do something like that, right? And you'd console log that or something to see what the value is. Okay, so we want to be able to export this file so that we can use it elsewhere in our project and so that we can run unit tests against it. So for that, Node gives us a special object called module.exports. And this is an object that we have that we can either overwrite it with an object of our own, or we can extend it by adding keys to it, just like any other object, okay? So we can use our regular object syntax. So if we wanted to export, say hello, we could either set, if we only had one thing to export, we could just say module.exports equals say hello, and that will export this say hello function. But if we had multiple things to export, you have a couple different options. You could do module.exports.say hello equals say hello, right? So you're setting a new property. Or you could do module.exports equals object literal say hello, which is ES6 shorthand for say hello, right? There's that ES6 again. So all of these will export say hello from this file and make it available to be required into other parts of your code. It's just dependent on how you want to require it. Okay, so if we were to require this, then we're just saying we would do require say hello equals const say hello, and this is going to error out like crazy, equals require say hello. Maybe it's in a different file somewhere, so we want to require that. But if we did it like this, well, then it's an object property. So when we say hello, to access the function, we'd actually have to say hello, say hello. Maybe I'll just put these in line underneath. So if we exported it like this, where the only thing coming out of the file is that particular function, we can import it just like that. We say hello equals require. Well, the only thing exported is say hello, so it's going to put the function right into there. Okay? If we export it as a property, then we have to say hello equals require say hello dot say hello. Or actually, this would be, I guess this is our file here, is str manip. And have we seen this anywhere else today? Yeah, in our testing file, right? So the way that chai is being exported must be something like this, where it's building out an object. And the same thing here. We would have to do const say hello equals require. It would actually be exactly the same. Oh, C, there we go, and Control V. So exporting it as a property on the object or overwriting the object, we need to dig into it to get it back. Okay? Yes?
So when you're going dot say hello, are you saying that it's a property of the say hello function?
No, well, no, it's actually a property of whatever was exported. So this export object is where say hello is a property of this object. And we need to get it back again with dot say hello.
And what would make you want to do that over just going with the first one?
Oh, over this?
Yeah.
It depends on how many functions you have inside of here that you're trying to export. If you have multiple functions, then you'll want to attach them as properties on this object. Because anytime you say, this is literally overwriting this code. This is saying module.exports equals say hello. Okay? Or versus this is being exported as a property on an object, and we need to grab say hello. And like I said before, instead we could use ES6 destructuring if you find that a little easier. So we're just requiring the entire file, but we're saying, I just want say hello out of that file. Okay? So for right now, we are just going to use this basic syntax of module.exports equals say hello. Okay? So in here, we need to bring that in, right? Because if we run our test now, which we're just passing, say hello is not defined. Say hello is not defined, right? This is more of our refactor. You can refactor by pulling things out to different files in your code base. Ultimately, what you want is tiny little files that do one particular thing, right? Because that's a lot easier to maintain than massive files that do all kinds of different stuff, and you're constantly looking around, where did I put that? Where's that in my code? Okay? So we need const say hello equals require. We need to go up one, and VS Code is helping us out. So we're requiring str manip from one directory up. And if we run our code again, npm run test, hey, everything's passing. So in a nutshell, module.exports is how we get code out of a file to be consumed inside of another file. Okay? Any questions about that? Yes?
When you put the dot, what does it change to?
What does it want? Oh, it's trying to use file as a common JS. It can be converted to an ES6 module. It wants to use the modern syntax, which is not fully supported, the import syntax. So we're not going to talk about that today. You'll talk about that later on in the course. This is the modern stuff, but it's not actually natively supported. So if we typed in import here, it's actually, you do it in a different syntax. You'd say import, say hello from ... manip. This won't actually work for us right now because it hasn't been fully adopted into the Node ecosystem yet. Okay? So this is a way that ECMAScript has defined a standard, but it has not yet been made available to all of us to use. Maybe a year from now, it'll be, that's exactly what we're doing. But for right now, let's just stick with module.exports and require. Okay? Cool. So we have 19 minutes left. Were there any functions last week that you dealt with? Anything like lighthouse in the house, character counter, anything from the prep course that you'd want to go over that we could write some tests for? Anything at all? Character counter is a fun one, right? Everybody loves character counter? Awesome. Cool. Why don't we set up some tests for character counter? So we're going to clear this, and we're going to touch inside of test counter.test.js. Okay, so now we have two files in here inside of our test directory. We can just jump right ahead. Const assert equals require chai.assert, describe, character counter, callback function. Also, another little thing, you may have noticed that when I type my code, I always put in my closing braces and my semicolons and everything before I move on. I don't just leave these and have this dangling and try to remember to do it later. I like to close everything, that way I know that I am inside of something. And it just helps me to write better code. And then I'm not looking around of I'm missing a closing something or other. Because when this starts getting nested, you can end up with things like this. And if you didn't do it at first, then you're like, how many of these do I have to get rid of? Whereas if you just do it all up front, everything's better. So, sorry? Oh, there's a question for Victoria. Can you do a test to show if something is an array? Yes, absolutely. So there's a couple different ways that we can do this. Let's go into assert. So we've decided that we're going to use the assert framework. And we have various different ones. Let's zoom out a little bit. And let's do a search for array. Didn't come back with anything. Awesome. You know what else is good for us? Chai. Assert is array. Hey, look at that. Somewhere on here is an array. Hey, there we go. Is array and is not array. So you can pass in assert dot is array and give it the thing. Give it whatever you think should be an array. Hopefully that answered the question for Victoria. And here you can see that we have is Boolean, is not Boolean, type of, instance of, include, deep include, does not match. You can see that we have tons and tons and tons of different options. And you can also, if you're stuck for something, I'm willing to bet that, if we go back far enough, somewhere in here we should see Stack Overflow. And you can see, oh wait, this isn't working as I was expecting. Oh, expect.equal, and you can see examples. So if you're not sure how to test something, just do a search on Stack Overflow, and someone will have written some handy answer that you can look at. Oh, expect foo bar to deep equal. Oh, okay. Remember when you were writing equality of arrays, and you couldn't just do array 1, 2, 3 equals array 1, 2, 3? Because we only have a reference to those, right? And it looks at those two references to memory and it says those aren't the same. So you had to start looping inside of the arrays and comparing them, right? So same thing here. If we say to deep equal, then it doesn't just look at the references. It goes inside the object and compares all of the keys, or goes inside the arrays and compares all of the values, right? This is stuff you've already done. And Chai does this by default by just putting in .deep. And then we can look deeper into it. Thank you. Perfect. Awesome. OK, so it should return an object of keys given a string. So now we're just testing the most basic thing about it. We should get back an object when given a string. Okay, so we're going to say const output equals character counter, lighthouse in the house. Assert dot type of, or do we have assert dot is object? Let's check. Chai. Check if object. Object has a property, it filled that in for me. Assert. Let's jump in here. Is OK. Let's do a search for object. Is object. Hey, that's great. We can just do assert dot is object. This extra here is an optional string that you can pass as a message that will output. And we can check that out. So all we have to do is say assert dot is object and pass it our value here. So assert dot is object output. What else should it do? Well, our character counter should return a specific object when given a string. And I'm just I would normally write this all out exactly what it should return, but I'm zoomed in so far. I don't want this to continue on and on and on. So we're going to test this out. We're going to say const output equals character counter. Let's do something shorter so that we can write a shorter test for it. Character counter A, B, space C. Okay? And we're going to assert dot, let's see how we do assert deep equal, deep include. What else do we have here? Oh, there's our deeps. Deep include, deep nested include, deep own. Is there a deep equal? Deep equal. Yeah, there we go. Deep equal. Perfect. So actual, expected, and then an optional. Remember that square brackets means optional. So dot deep equal. So deep equal. Thank you, VS Code. Output. And we're just going to put an object literal here. So we should see A has 1, B has 1, and C has 1, right? Because there's one of each in there. Does that stack up to what you did last week with Lighthouse in the House and the character counter? So it should return an object that looks like this, right? Maybe let's throw in it should be able to handle, and I'm just doing this because we only have about 10 minutes left, should be able to handle multiple characters in the string. Fat arrow callback function. So const output equals character counter. We're going to pass it A, B, C. And so what would come back from this? Assert.deep equal output. And what would this object look like based on last week? Well, there's 2 A's, 2 B's, and 1 C, right? That tracks with what we had going on last week, right? So A, B, C would return A has counted 2 times, B counted 2 times, C counted 1 time, right?
What was the object you wrote above? Why did you write that one?
This one here?
Just another example?
Well, here we're just testing to see whether the function actually works. Here we want to make sure. Normally, if I had another 20 minutes, I would have done this one, and then I would have given it an example sentence that had multiple. Because remember, if any of you struggled with this, sometimes you came back with an object that just had all of the keys and 1, 1, 1, 1, right? Did anybody have that? Or was that just me? Okay, so it's very frequent that, remember that you had to plus equals if you'd already seen it before, or you just set it equal to 1 the first time. If you set it equal to 1 the first time, this test will pass. If you set it equal to 1 the first time, this test will fail. These are how you avoid happy path testing. You want to test as many different ways that your code can fail as possible, okay? So we're going to run these tests now. npm run test. Ooh, there we go. Okay, so we can see that our tests for strmanip, our tests for our say hello function, still working perfectly. We had 2 of those tests pass, but now we have 3 failed. Character counter is not defined. So instead of declaring it, because we only have 10 minutes left, instead of doing it in this file, I'm going to create a whole new file. Touch character counter.js. There we go. Character counter. Remember, we want to write the minimum amount of code that's needed. Counter equals function module dot exports equals character counter. There we go. So we are exporting it, and let's require it into here. Const character counter equals require up 1 directory character counter. Okay? This is exactly what we did before. We're just putting it in the module.exports object. Okay? Now, let's hope that our red turned to green somewhere. npm run test. Ooh, different. Expected undefined to be an object. Expected undefined to deeply equal A1, B1, C1. Expected undefined to deeply equal A2, B2, C1. Okay? So now we have some more work we need to do inside of our character counter. We need to accept a string of some kind, right? And does anybody remember how they implemented the character counter? We had to remove all the spaces, right? Remove the spaces. So str equals str dot split on spaces dot join back together with no spaces. So we've split it into an array and we've joined it back together again with no spaces in it, right? And now we need to loop through the string, right? So for const, let's do for of, I think that'll work for us. For const char of str. And let's set up a return object, const result equals that, and make sure, this is more of what I like to do, make sure to return result. So we can actually test this now to make sure that we haven't broken anything else. npm run test. Oh, hey, look at this. We're actually getting back one of our tests passed. It should return an object because that was all our first test said, is the expected return value should actually be an object. Assert.isObject output. So we've actually made one of our tests pass. So now we just have two more that are failing. It expected empty object to equal this object. Okay? So the next thing we did in character counter, we looped through all of our chars and we tested to see if result at char, right? Had we seen that character before? If we have, result at char plus equals 1. Else, if we haven't seen it before, result at char equals 1. That seems like a minimum amount of code. What happens if we run the test suite again? Hey, look at that. 5 tests passing. Okay. What I was talking about before is I've seen a lot of students do result at char equals 1. And if we run this test, we run our test suite against this test passed, right? The one that only had one of each letter in it passed. So if you're just writing your tests and you're like ABC, great, test passed, moving on, then maybe your code isn't actually doing what you wanted. And we can see that down here. We see that we had expected A1, B1, C1 to deeply equal A2, B2, C1. And we can see it's showing us in our console, rather than us having to console log and look and compare, it's actually showing us this is what we were expecting. We expected the green, but our actual result was the red. Okay? This is how tests will be set up for us and how you're going to write your own tests. So there we go. Hopefully I didn't go too quickly through character counter there. We have 5 minutes left. Are there any questions about anything that we did today? Would you agree that we were test-driven today? Okay. So hopefully we demonstrated that. Let's look back at practice unit testing. So unit testing is one particular type of testing. Unit testing is the simplest thing. We're testing each individual unit of our code. In this case, one particular function. There's also end-to-end testing and things like that that you may or may not get into as you move through. But unit testing is absolutely the most basic. We feed parameters into a function and we test the result that we get back. It's the simplest thing to reason about because you've already been doing it. You've already been saying console log the result of this function. That's not what I was expecting. But instead, we're formalizing it. We're saying it should return an object. It should return a specific object. It should be able to handle multiple of the same characters in the string. We're actually defining what our code should look like before we write any of it, and then we haven't wasted any time when we're writing our code. We write some code, we run our tests. We write some code, we run our tests. once all of our tests are passing, we can refactor our code. And we're confident in the fact that if our tests pass, we're still good. So we practiced unit testing using Mocha and Chai, and we created and consumed modules using Node's default module.exports and require syntax. Cool? Any other questions? Oh, Terrence is typing. Any questions in Vancouver while we wait? No? Yes? Oh, yeah. Okay, let's do that really quickly. So we have character counter in here, and let's say we also have our say hello function in here. Takes a name and returns hello name. So since we now have multiple, we can't just use this syntax anymore. So instead, we can either, like I said, you could say dot character counter equals character counter and module.exports say hello equals say hello. Same way you can add properties to any object in JavaScript, or alternately, this is a big or, module.exports, and this is what you'll see most commonly, character counter and say hello. You'll usually see it in this way, that you're exporting an object and here's the key and here's the value. And it's simply because then you don't have to type out module.exports.characterCounter equals character counter. But now our tests, I save this and then jump back over here, we refactor our code, run our test. Oh, character counter is not a function because of the way that we're exporting it now. So when we import it, we need to say dot character counter, right? Because we're now exporting, instead of exporting just the function itself, we're exporting an object that has a key that is the function. And now, when we run our tests, everything passes again. Can you show if an input function parameter should be a number? That one would be more difficult because what you're doing is when you write an assertion, you are asserting that the return value from the function is something. We want to stress, remember when I said at the beginning of the lecture that ECMAScript defined the standard, but it's up to like Google or Internet Explorer, like Microsoft or whatever, to write the machine that actually reads in your JavaScript and outputs something. We don't care what the implementation of. There's various different ways that you could have written character counter to do it differently, right? We didn't need to use a for of. We could have used a C-style for loop. We could have used a for in. We're testing output, especially for Terrence. We're testing the output. We're not testing the implementation. So we want to separate those two ideas in our mind. When we write an assertion, we're saying, what is the output of the function? I don't care how you made it do what it needs to do. I only care that it's output, because when we talked last Thursday about why do we write code and what are we writing it for, we are abstracting complication, all those that complex thoughts and ideas and the implementation, we're abstracting that away so that when you consume it, you just write, where's our character counter? You just write character counter lighthouse in the house, right? You want to just be able to use this character counter function, which I'm going to drag around. There we go. You want to just be able to use character counter wherever you want. You don't care how it was implemented. Maybe you wrote it. Maybe some other dev wrote it. Maybe it's part of a package that you brought in, something like that. So I want to separate that idea of the implementation, what happens inside of this function, from what this function says to the outside world. Does that make sense? Okay. Did that answer the question? And let's look, 12:01. If there's no other questions, I'll let you get on with your day. One thing I will say, though, TDD is extremely important. Hopefully I've shown that it's beneficial, but not enough teams do it. So if you join a team that's not doing it and you start implementing tests, your seniors will be very happy with you. Okay? Because everyone wants to do tests, but no one actually wants to do tests. So be the person who wants to do tests. Okay? Awesome. Enjoy the rest of the day. Thanks.